If you just want to learn Cisco Packet Tracer in 1 hour, then this is the video for you. So in this video, we're gonna go from very basic, from interface, how to work with the application, to more advanced stuff like simulating IoT, simulating your own HTTP service, simulating FTP. We teach you how to work with wireless connections, how to work with wired connections, how can we have two switches with different IP ranges and connect them with a router. We have simulating DHCP, simulating email servers, FTP, and there's so much fun in this video. So don't miss this video. And if you want to learn these things, stay with me. It's just 1 hour and half an hour. So uh, it's basically 3 episodes of Rick and Morty. So stay with me. Don't leave this video, and let's start. Alright, so let's get a little bit more comfortable using Cisco Packet Tracer and get familiar with the user interface. So at the top menu we have the regular applications menus like new files, save as, saving files, open recent files, things like that, and there isn't much we need to change in the menu bar because we have the toolbar here at the bottom of that is the all of the necessary things that we are going to use in the menu bar, options that we have access to all of them in the toolbar. So if you're using an older version of the Cisco Packet Tracer that has a little bit of yellow bluish color theme, these menu are you can see them at the right of your screen, but in the newer version that I'm using, it is in top and it's close to the toolbar. So nothing special, it's just the select tool, the zooming tool, I think it's inspect, and delete tool. Here we can place a note, we can place shapes and things like that. We're gonna get familiar with the packets and the tools up here. So after that we have the logical and physical tab. So the program of Cisco Packet Tracer divided by two parts. One of them is logical and one of them is physical. The logical tab, here we have a big screen that allow us in the logical tab to set our stuff, set our computers, set our routers, set our switches, and connect them together and have a connection in the logical part. We can do that. And in the physical part, we have distance measurements, like we can set the distance between two computers, the distance between a mobile and the access point. We can set things like that. So in the physical tab, we have a home city. We can create new cities from up top right corner here. We have create new city, so I can create a new city. So if we want to simulate the connection between two cities, right? Or when I click on a city, we have a company here. We can add another company as well. We can have two buildings for simulating the connection between two buildings. And smaller, again, we have rooms inside a company. It's a floor inside that company that we have rooms. And inside of that, again, we can have a main wiring closet. In the main wiring closet, we can have racks, we can have tables, and that's the last part here. Here also we have a menu for moving things. For example, we're gonna move our computers on the table, so we can do it in the menu tab, which I'm gonna show you in the upcoming tutorials. Then the main part at the bottom, we have the devices. So you might have a little you might see a little window over here. It's called the scenarios, and this is just by you can activate it by a little flash if you're using an older version of Cisco Packet Tracer. I think it's hidden by default, but in the newer version it's open by default, so you can open it and close it by that. So I'm gonna tell you what it does in the upcoming tutorials. And after that we have a real-time and simulation, which in simulation mode we can send data from a computer to another computer and visually see the data transmitting through the cables, through the devices. So it's for testing purposes, but for in real time, as the name says, we can test it in real time. So here is the time that is passing by. This is the real time that we spend in the application, and this is the time I think multiplied by 30. Each second here is 13 seconds over there. So we can change the time pace that it is moving just by clicking on it and going to edit. Here you can see, oh, it's each minute. Each minute is equal to 30 minutes in the simulation. So it's because in the time consuming connections, the connection go faster, so we don't need to wait so long like in the real world. And the devices, we have so many devices in the networking devices. We have routers, we have switches, we have access point for wireless devices, and all kind of things. In the end devices, we have the PC, laptop, servers, and smartphones. Here is the smartphones. So then we have the here is a smart city, and here the things for a smart home, like the cafe machine, the AC. We have all kind of things that we are going to work with in the upcoming tutorials. Then we have cables, all kind of cables we are going to use to connect our things together. Let's create our first networking simulation. So for creating a connection between two computers, we need two computers, right? So go to the end devices, and from here I click on the computer. For adding the computer, just click on it, and then your mouse will change when you go to the logical tab. Click anywhere and the computer will be created. If you want to create multiple computers, I believe you just hold control on your keyboard and you can create as many computers as you want. Alright, so I don't need these many computers, I just need two, so I will delete these. Okay, so let's select the select tool, and here we have two computers over here. Okay, now let's connect them with a cable. So the cable that we need to connect two computers are the copper crossover cable. We click on it, fast Ethernet, and on the fast Ethernet. Okay, the two dots here are green. So when it is green, it means the connection is stable. And let me remove the cable so I show you the auto connect. There is a lightning here, as you can see. It says automatically choose connection type. So if we click on it, it will automatically choose the proper cable for our connection here. So we are using the copper to connect two computers together. So there might be another cable for another situation, like for example connecting a switch to another switch. So now in order to have a connection between these two, we added the cable. Now we want to transmit data through that cable. In order to do that, we need an IP address for each computer, so we can send the data to an address, because the IP address determines the address of the computer. Right now they don't have an IP address and they cannot find each other, so let's give them an IP address. If I click on the computer, you can see this window is coming up, and this window is a very important window because we're gonna configure our things into the computer. The setting of the computer is here. So in the first tab, which is physical, we have the physical part of the computer. For example, I can turn it off or turn it on just by clicking on the turn off button. You can see the triangles goes red. So if I turn it on again, it will be turned on again. And in this video, we can add modules. What are modules? Let's say, for example, we want to connect this computer to a wireless network. So we need to add the wireless module for the computer. Or other modules like the headset, like microphone. For adding modules, just click on the image of the module bottom right corner. Click on it, hold it, and I can drop it on the computer, on the specific pin that has been created for the microphone. So the headphone is the same. I cannot leave it anywhere in here, just at the right place of the headset. So the headset and the microphone can be added as easily as that. But if we want to, for example, attach a wireless module, we need to turn off the computer. So it won't let us to add it just like drag and drop it. The computer need to be turned off. And that's that. And let's remove the headset and microphone. So in order to set an IP for the computer, we have two ways. One of them is in the config window. In the config window, we have the fast Ethernet. If we click on it here, we have the IP configuration, and there is a DHCP and a static IP that we can set. The static is using by hand, and we're gonna give them a static IP that only we know. The DHCP will give them an IP automatically from a DHCP server. So we have a particular video for that, and in the upcoming tutorials we are going to create a DHCP server and give IP to a bunch of computers automatically, but not in this video. So in this video, I'm gonna put an ipconfig this static type. The second way to set an IP address is by going to desktop. Desktop is a more visual feeling, give you a visual feeling like we have web browsers, we have a PC wireless. If I click on it, well, it will tells me that I don't have the wireless module right now, but we are going to work on it later. So we have command prompt and so many things that we are going to work with. But also we have the IP configuration here. So if I click on it, here is the IP configuration part that we have access to all. So the IP address that I'm going to set, I will set 192.168.1. Let's say 10. Okay. If I press enter, the subnet mask will be set automatically. So if you have a particular subnet mask, you will set it here as well. So that's it. Let's set an IP address for this computer as well. IP configuration 192.168.111 this time. Okay, press enter. The subnet mask will be set automatically. Now we want to test the connection. So the easiest way is by clicking on the computer, go to command prompt, and get a ping from the other computer IP address, like ping 192.168.1. This computer was 10 and the other one was 11. So if I click enter, you can see it's giving me the ping. So the connection is stable and we can transmit data from these two computers. And that's the easiest way to test the connection. The other way is by sending a packet. So I told you in the previous video that we're going to see how packets work. So the packets, just click on this mail icon and click on the first computer and click on the second computer. And the first computer is where you want to send the packet, or the computer that is going to send the packet. The second computer is where the packet is headed to. So in order to test this connection, test this packet, which we call scenario, here we have multiple scenarios in this video that I told you in the previous video. We can have multiple scenarios, multiple packets being sent. So right now we have one packet sending from PC 0 to PC 4, and for testing it we need to go to the simulation tab over here and press on this play icon. If we play it, you can see the packet will be sent to the PC 4, and it will go back to the PC 0 because it's using a TCP protocol, and the TCP protocol works this way that when the computer sends the packet, it needs to receive a packet that it says that the second computer says that yes, I received your message. So just like that, and the packet sent it successfully, and we know that the connection is stable and we can communicate. So let's delete this scenario just like that, and here we have a connection between two computers. I will save this project, and as also for all of the other videos that are coming, I will save every project. You can download them from the description. So if you have homework, if you want to study them, you can find them in the project in the link in the description. For the start topology is this way that we have a switch and all of the computers are connected to the switch and communicating through that switch. So in case to create an start topology, let's go to network devices, routers, switches. Oh, sorry, no routers. Network devices, switches. Okay. I just select the first switch that is there. So let's add another computer as well, and let's delete the wires. So, okay. Now let's connect all of them to the switch. You can see it's red in the other side, in the switch side. It's because it takes a little bit of time to establish the connection. It will turn green in a little bit. So in that time, let's assign the IP address for the computer. So the PC 0 was 192.168.110. This was 11, and let's give this one 12. Okay, you can see the connection has been established, and now let's communicate through the connection. I'll say ping 192.168.1, and let's say 12. Okay, you can see now the connection is stable, and we can communicate from the computers. And let's send the packet as well from the 10 to 12, and let's start. Okay, we can see from PC0 to switch, and from switch to PC1, again back from PC1 back to switch, and from switch it will go to PC0. That says yes, I received the message and the packet sent it successfully. Okay, we can either reset the simulation, so do it again, or delete this scenario. We can also create new scenarios, like in these scenarios I'm gonna send from the PC4 to PC0, and when I send it, you can see this scenario is working perfectly, and we have the scenario 0 now and scenario 1. So this is how we can create multiple scenarios. Let's just delete both of them. One thing I forgot to tell you in the last video was that the connection between PC and switch, if you noticed, we are using the straight cables right here, but in connection between PC to PC, we was using copper crossover cables. So let me create two other computers and one more switch so we can simulate the connection between two switches. So before doing that, let's go to the physical tab. I'm gonna show you how we can work with the physical tab. So this city, I don't think we need it. Let's delete it and go into the city. This building as well, we don't need it. In the first building, you can see now that I have one computer over here. Alright. If I open up the closet, you can see two computers are here. Both of the switches are in one rack. So in this simulation, let's assume that we have a bunch of computer in this room that are connected to the first switch, and we have a bunch of computer in this room that have the other switch. So first of all, I want to create a main wiring closet. So main wiring closet is this one. Here, wiring closet created, and the PC2 and 3 gonna be in wiring closet, the second wiring closet, let's say. Okay, let's go for moving them. We use the I think it's navigation or physical location tab. Okay, so here the new wiring closet we created. So PC3 and PC2 gonna be in this wiring closet, and the second switch 1 that we created gonna be in this wiring closet as well. And we need a rack, so to create a rack, let's go here, create new rack, and let's take our switch to the rack. Alright, now let's go back and take the other computer that is not inside the wiring closet, also put it in the wiring closet. Now these two have different wiring closet, and they're both in the two different rooms. It's not gonna have any effect on these parts because it's all wired up, but in the wireless connections you can clearly see the signal strength that in the distance is so affect the strength of the signal. So let's wire up the computers and the switch, and for computer to switch we use the straight cables, but for switch to switch again we use copper crossover cables. If I connect that, you can see it's a crossover cables. So it is red right now because it needs a little bit of time to connect. So in that time, in the meanwhile, we're going to give IP address to these two. So let's say the IP address here is 192.168.1, let's say 20. And this is gonna be 21. Okay, the lights are green now and the IP address has been set. It means that now we can communicate between these computers. So let's send let's get ping first. Get ping from the first computer that was 192.168.110. Okay, you can see it's giving me ping, and these two are communicating, and let's send a packet now from this one to this one. Go to the simulation mode, Sending the packet, okay, from PC3 to switch 1, from switch 1 to switch 0, and from switch 0 to PC1. Then goes all the way back to the PC3 again. Alright, so it has been successful, and I will delete this scenario. Alright, you can, I've saved the file for the Cisco Packet Tracer and put it in the description, a link to the description. You can download the project file for this video. Now, we want to simulate a situation that, let's say we want to connect these two switches, but the IP range for this switch is different from the other switch. And in order to do that, we need to use a router. A router is something between that are gonna get between these two to convert the IP range so they can communicate together. I will add the 1941 switch. Oh, sorry, it's router. 1941 router, and let's remove the connection between the switches. And I want to have a connection between this switch to the router and this switch to the router again. Alright, so the router is not using the fast Ethernet, it's using gigabit. Let's see what has the name. So gigabit Ethernet, yeah, gigabit Ethernet to. Alright, so we connected the switch 0 to gigabit Ethernet 0 and switch 1 to gigabit Ethernet 1. Now what we need to do first, let's change the IP range for these computers. So let's say, for example, it's gonna be 172.16.1.10. Okay, let's save it. Alright, let's go to the real time. Alright, the IP of this one gonna be 172.16.1.11, and let's the subnet mask will change as well for this IP range, and that's it. So now we need to set up our router. So to set up our router, let's just click on it and go to the config. We have two things that we need to change. One of them is inside the gigabit Ethernet, and the other one is gigabit Ethernet 1 for the switches. So gigabit Ethernet 0, we connected the switch 0 that has the IP range of 192.168.1. We connected this switch that with this IP range to the router gigabit Ethernet 0. And we connected 172.16.1.1. Okay, this is the IP range for this switch. And so gigabit Ethernet 0 gonna be 192.168.1.1. Alright, the subnet mask will be set automatically. And one other thing that we need to do is to set the port status on so they can communicate together. The port status, if it would be off, they cannot, it is turned off basically. So let's set the IP range for this one as well. Okay, and one thing we need to do now, there's one more thing we need to do, one last thing, is to set the gateway for the computer. So inside the IP configuration in each computer, we have a default gateway. So we set an IP for each of these ports that the switches are connected to. But we need to tell them that which gateway they're gonna cross to access these switches. So these two computers gonna go through the 192.168.1.1 gateway. Okay, and this computer as well. Gonna go to IP configuration. The gateway gonna be 192.168.1.1, and these three gonna go through 172.16.1.1. I'll just copy the IP and paste it for the rest of them. Okay, now we are ready to go. Let's test the connection. Let's go to get a ping from 192.168.1.10. Let's wait. Okay, it's okay. You can see the first one has a request timeout, but the other ones give me the ping. So it took a little bit of time for it to connect to the PC0. And let's test the packet as well. Let's send the packet from here to here. Okay, from PC1 to switch 0. From switch 0 it goes to router. You can see it sent it to the other two computers as well, but they didn't respond to it because the packet weren't meant for these two. Alright. So what happened here was that once the switch that sent it to the other PCs, why did it do that? So it was because first it needs to check that, let me stop the simulation. First, the switch needs to check if the IP address is connected to itself. Then it will go to the router, check the base IP address, and go to the PC and say that, yes, we have this IP address here. So then it will go back to the router, go back to the switch 1, go to the IP address that was meant to be sent. Now let's go test a wireless connection. So for wireless connection, we need an access point, which is in the network devices, wireless devices. So I'll choose the simplest access point possible. It's access point PT. And now we need a bunch of devices. I will select a PC, a laptop, and a smartphone, so you can see how we can work with 3 of them. Alright, you can see the phone connected immediately because it doesn't have a password yet. So first we need to set the name or SSID and password for our access point. Let's go to the access point, config, and in port 1, the port 0 is for wired connection, and port 0 is for wireless connection. So the SSID is the name of the Wi-Fi. When you turn on your phone and go to the Wi-Fi settings, all of the Wi-Fis that are shown, the name of them is the SSID. So I'll put dgdev for the SSID, and the password type gonna be in the authentication. I will put it VPA2 PSK. It's the most secure password type for access points you can get. So 1 2 3 4 5 6 7 8 9. All right. I'll just put a simple password. So now you can see the connection between the smartphone and the access point has been disconnected because we set a password for the access point. So let's connect the access point. First, let's test the PC. In order we connect to the access point with the PC, first we need to add the module for the wireless connection. And in order to do that, first we turn off the computer. The already installed module is for wired connection. We will take it and put it in the module to remove it immediately. And the module that we need to add is VMP300N. So let's take the module, replace it with the old one, and turn on the computer again. Now we have access to the wireless. We can access to the wireless, and in the desktop we have a PC wireless. Let's click on it. You can see it has a nice menu. It's all visual. We can add it in the config wireless with the SSID and password we set for the access point, but let's do it in the visual section of desktop. Okay, so in the connection you can see here we have dgdev with 39% signal. And the physical tab, if we go here, you can see a circle, purple circle, that is the radius of the strength of the signal. So if I click on it, you can see the wireless is on the main wiring closet. And let's put the PC and the other devices inside the closet. Okay. Now if I go here, again in here, let's refresh. It will take a little bit of time, so if it didn't find it immediately, just wait. And you can see here the signal is 100% now. Let's click on it, send connect, and here we need to add our password, pass 1 2 3 4 5 6 7 8 9. So let's say connect, and you can see our connection has been established. And for the laptop is exactly the same. Weirdly, laptops in Cisco Packet Tracers don't have the wireless connection by default, wireless module, and so we need to turn off the laptop just like the computer and add the wireless module for the laptop. And let's turn it on again. Go to desktop, PC wireless, connect. Let's wait a little to for it to find the wireless. As I said, it might take a little bit of time, so be patient and do not close the window. Okay, now it's taking weirdly long time. Okay, it found it. Let's put the password and hit connect. Okay, it's connected now. And for the mobile, one thing that is the mobile doesn't have a visual place to connect to the Wi-Fi. We need to do it manually in the config, wireless 0, and in the VPA to PSK. Here is the password type that we set, and here is the password. Okay, press enter and close the tab. It will connect in a second. In the meanwhile that it's connecting, let's go add an IP address for each of them. So the IP address gonna be a static, gonna be 192, 168, 110. Oh, one thing I forgot to do for the mobile is to set the SSID. The SSID was DGDEP, so we didn't set the SSID that is going to connect because of that it took a little bit time. So now that we changed it, it connected immediately. And the IP address, I will just copy it and paste it and set the 10 to 11. Okay, for the smartphone as well, gonna be 12. Alright, now let's test the connection. So let's test sending a packet from the computer to the mobile. Let's say go to the simulation mode and send the packet. Okay, you can see it's processing the packet access point. Let's see. Okay, it sends the packet to all of the devices, but the other devices weren't meant to get this packet. It's meant for the specific IP address of this smartphone, and the smartphone receive it and send it back to the access point, and the access point send it back to the PC. Okay, now let's test a scenario that, let's say we have an access point with a wireless connection, and we want to connect it to a switch with a bunch of computers connected to it. So basically, we want to have a wired connection connected to a wireless connection, and the devices can communicate to each other. So let's have our access point over here, and let's create a switch over here. Let's connect two computers to the switch. Alright. And let's connect the switch to the access point. One thing that is important here is go to the access point setting, port 0, make sure the port status is on, otherwise it won't work. So the port 0, I told you in the previous video, it's for wired connections. So we can connect our switch to the port 0. And let's set the IP for these computers as well. I'll put 192, 168, 1, let's say 5. Oh, we are in the simulation tab. Okay, 192, 168, 6. Okay, now to test the connection, let's send the packet from the laptop to the PC1, and let's test it. Yeah, I'm just gonna skip the process here. You can see it's, maybe we can set the speed a bit higher. Okay, now here you can see in the event list, you can see what happened. And the packet went from the access point to the PC and other devices. Here is the first run with the, let me stop it first. So in the first run, it went from laptop 0 to the access point, then to access point switch to PC1, PC1 again to the switch, from switch to the access point, and the access point sent it to all of the devices again. So our connection is stable, and we can communicate between the devices. For simulating a DHCP, which stands for Dynamic Host Configuration Protocol, first of all, let's add 3 computers, and then we need a server, and at last we need a switch. Alright, so with DHCP we can automatically set the IP address for our computers in a predefined set of IP addresses. So let me do the connections. Okay, now that we have attached all of the devices together, we need to configure our server. So open up the server. In config, first of all we need to attach an IP address for the server its own. Go to the config, fast ethernet, and the IP address for the server, I'm gonna give it 192.168.1.1. So this is gonna be the IP address of the server. So because the computers need to find the server, so this IP is for finding the server. You can see here we have an extra tab which we didn't have in the computers or smartphone, which is services. That is the services available that this device can give to other devices. So in the servers we have in the Cisco Packet Tracer, everything is already assumed that it's installed on the server. So DHCP, HTTP, and everything else are available. So we just need to determine which one we're going to use. And in DHCP, let's turn on the interface which we're going to use, DHCP. Then here we have an item. Let's select it, and here is the settings that we're going to set for our server, DHCP server. So I'm gonna say that it's gonna start from 192, 168, 1, and 10. So I'm gonna give it 10 because now every device that we're going to use DHCP for the IP, the first one gonna be, for example, 10, the second one gonna be 11, the third one gonna be 12, and goes on. So here is the maximum number of users that we want the DHCP server to automatically give them IP address. We can set, for example, 2, that after the second computer, the third one cannot get an IP address from our DHCP. So let's give it 10 for now, and let's save it. Make sure to hit the save button so the changes will be saved, and let's close it. Now the only thing that we need to do is to go to the computers, desktop, IP configuration, and here set the DHCP to check the DHCP. You can see DHCP request successful, and the IP address is now 192.168.1.10. And for the second computer, let's assign DHCP requesting IP address, and the DHCP request successful. Let's do it for this one as well. Alright, now let's send the packet from the PC0 to PC2. And in the simulation mode, let's see. Okay, going to a switch, and switch, going to send it to the PC2. And then again, it goes back to the switch and back to the PC0. Alright. Now that we have an DHCP server, let's go further and create an email server. So I'm not gonna turn off the DHCP. We're just gonna use the email server on top of the DHCP. So the computer is gonna use the DHCP to automatically get IP address. So here on email, make sure that SMTP service and POP3 service is on, and if they're off, turn it on. So the first thing is that we need to give it a domain name. So the domain name of here is completely on your own. So for example, the domain name can be gmail.com or yahoo.com. Set anything that you like. I want to set gmail.com. This is a custom domain, but let's use gmail.com for this tutorial. Then click on set. So make sure to click on set, otherwise you will get an error when you want to send emails. Then we need to create some users. So let's create a user called dgdev with a password of 123. Add it. Now the user has been added. Let's create another user called Ali123. Oh, Ali, and the password gonna be 123. Add it as well. Okay, now we have two users that we can go log in into the computers now. So go to the first computer, desktop. We have an email section. Let's open it up. And here we need to set some configuration. So your name gonna be the name of the Gmail, which is Ali. The email address gonna be ali@gmail.com. Incoming mail server. So the IP address of the server that we have set in the previous video, which was 192.168.1.1, and the outgoing for incoming and outgoing we are using one server. So just copy the IP address of incoming mail server. So the username and password is the username and password we set in the mail server, which was Ali and 123. Save it. Now we are logged in. So keep that in mind. If you set any false information or your information is not right, it will not give you any error. So make sure to set them right. So if you're not getting any emails or your emails not being sent, it might be because the information that you set here is wrong. So keep that in mind. Okay, for second computer, let's log in to the other email. Okay, let's open up email. The name was dgdev. Alright, email address will be dgdev@gmail.com. The incoming server and outgoing server, and username and password. Save. Here we are. Now let's send an email to the Ali. So for sending email, just click on compose to ali@gmail.com. The subject is test, and the description gonna be test as well. Let's send it. Okay, it has been sent. And now for seeing the email that we have sent it, let's go back to the PC0, go to emails and receive. We need to click on receive. So you can see in this date, the DGDev has sent us an email, and if we open it, you can see here the subject, the email that has sent it this email, and the text. Alright, so that's it. That's how mail servers work. To simulate an FTTP connection, we need two computers, two servers, and one switch. So why two servers? It's because one of them gonna be the FTP server and the other one gonna be the DNS server. We actually don't need the DNS server in this situation. We just need we just need a device to act like a DNS. We not even gonna use the DNS services that we have installed here. So the only thing that we need to do is go to the IP configuration, set an IP for the DNS server. Let's say 192.168.1.1. Okay, this is gonna be the DNS server IP address. So let's put the IP address for the DNS server as well. So the DNS server that has this IP address is gonna be the DNS for its own as well. Okay, and also let's change the name of the servers. So the name is the text that's showing over here. You can go to the config settings and display name gonna be DNS. Okay, and for FTP going to be FTP. Alright, now let's connect everything together. Okay. Now let's set the IP address for the FTP server. So the DNS server gonna be the IP of the DNS server, and the IP address for the FTP, I'll just say it's 100. And for the computers, we need also give the DNS server and an IP address. I will just say 2 for the PC 0, and for PC 1 gonna give it 3. Don't forget to set the DNS server. Alright, now we are ready. We just need to configure the FTP server. So let's go to the FTP services, and here we have a section called FTP. Let's click on it, turn it on, and here we need to create a user. There is a default user with the username Cisco and password Cisco that has all of the permissions. The permissions are, as you can see here, write, read, delete, rename, and list. So let's create a user with name Ali and password 123, and I will give it the access just to write and read. Let's add it. Here is the user. Okay, now let's test the FTP server. Now go to command prompt and okay, now for connecting to the FTP server, we just need to type FTP in the command prompt and the IP address of the server. So the IP address was 192.168.1.100. Press enter. It found it, and it need a username and a password. So the username was Ali and the password was 123. Okay, I entered the password, but remember that you cannot see the password. So if you're typing and seeing nothing being showed here, so remember that the password won't show, but it is entering the password actually. So now to test the FTP server, we need to upload a file. So now we saw that we can connect to it. Now we are the FTP server is active. Everything is all right. Now we need to send a file. So normally in the Cisco Packet Tracer, everything is a simulation. So we don't need to send a real file. So there is a text editor that we can create files inside it. So let's create a file. Let's say blah 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 blah, and file. Save with the name. I say AA. Let's just say AA. Okay, now we have a file called AA. Now in the FTP server, let's say put, for sending the data we use put the name of the file, aa.txt. Do not forget to set the type of the file that we have entered. Okay, put aa.txt, enter. You can see the file has been uploaded successfully. And for retrieving the data, the FTP is still open. To get out of the FTP, just type quit, and you will go back to the C drive. Alright, now let's go to the PC1. Now we want to download the file that we have uploaded from the PC0 to the FTP. So now in PC1, we're going to download that file inside our computer. So let's write, first we need to connect to our FTP 192.168.1.100, and the username and the password. We are logged in, and now for retrieving the data, the command is get. We say get the name of the file, aa.txt. Okay, now you can see file transfer in progress, and the file has been completed. The transfer has been completed successfully. And for seeing the file, we go to the text editor, file, and open. You can see here on my computer I have aa.txt, which it is in PC1. And if I open it, you can see the text that we have typed in the file. For simulating an HTTP service, first let's add 3 computers. Alright, then we need 4 servers. Let's add 2 here and 2 here. Okay, now for connecting all of this together, we need a switch. Okay, it's done. And now let's determine which server is going to do what. So in order to have an HTTP service that we can open up websites, we can create websites, and the clients can access our websites, we need an HTTP server, which are the our website servers, which is going to be these two. One of them going to be Google server, one of them going to be Yahoo server, just for examples. So, and the other server is going to be, one of them going to be the DNS, and the other one going to be the DHCP server. So the DHCP for giving our computers the dynamic IP, and the DNS I'll tell you in a second how we're going to use it. First, we need to see how the DNS works. So in previous videos, we understand that in order to communicate from one computer to another computer, they both need to have an IP address. And so when the two computers have the IP address, we can communicate between those two. And in order to communicate with the server, we also need an IP address. So the way that the website works is that inside that server we have all of the files of our website. Any request that we send, it will be processed and show us a static page from the server. So we are communicating with the server directly from when we send a request from our browser. But the way that we are communicating is with the IP. But why do we have an address for google.com? How does it know that which IP address it's going to connect to? So that's what the DNS does. The DNS have a list of IP addresses and of domains. So it will connect each domain to the IP address. Let's see how. For example, it have a list. Let's say it says google.com has an IP address of 192.168.1.1. It has a list like this. So it says this address has this IP address. Okay. And let's have it here. And the way that we do communicate now with the server is to first we will send a request to the DNS. We say which IP address is this address connected to, and it will give us the IP address. Then we send our request to the server that has that IP address. Alright, so now let's set a name for these servers. So this is going to be DHCP. This is going to be the DNS. Let's say this is Google servers, and this is Yahoo. Alright, now each of them need an IP address. So for the computers, it is a DHCP. DHCP gonna have an automatic address for the computers. But for the other servers, we need a static IP. So for servers, we cannot add an IP address with a DHCP, an automatic IP address, because it might change when we turn off and turn on the servers. And so that's why we need a static IP address. So let's set a static IP address for our servers. Go to the desktop, IP configuration, and in here, let's add 192.168.1.1. This is going to be for Google. And I will copy this, and for Yahoo, I will add this, maybe the difference of one number. It's going to be 192.168.1.2. And let's say that the DHCP going to be 3, and the DNS going to be 4. Now there is a very important thing that most of the people forgot to do, is to set the DNS for the DHCP. So let's go to the services and configure our DHCP. In order to configure the DHCP, first we need to turn off all of the other options except DHCP. Let's turn off them first. Okay. Turn it off. Turn it off, and alright, now let's go to the DHCP and turn on the DHCP. So here we need to set first a DNS server, because we have a DNS server that's gonna have a list of the IP addresses and the domains. So in order to connect automatically to that DNS, we needed to set it in here for the computers. And the DNS is gonna be 192.168.1, and it was 4 for the DNS. Okay, and I'm gonna say the IP addresses, I want them to start from 10. So for computers, it's gonna be from 10, and save it. Alright, the DNS is ready, and oh sorry, the DHCP is ready, and let's set the IP address of our computer to DHCP. Okay, the DHCP request was successful. You can see the DNS server will be set automatically with the DHCP as I told you. Okay, and set this to DHCP as well, and this one as well. Alright, now we are ready to do our things. So the thing that the first thing we're gonna do is to configure the DNS server. To configure the DNS server, let's just open up the DNS, go to the services, turn off everything except DNS. DHCP was off by default. Off and off. Alright, the reason that we turning off everything except the thing that we want is because when we have multiple servers and multiple things for a specific purpose, it can we can have errors because it's gonna, for example, have an DHCP automatically, and if you have, for example, two DHCP for two different purposes, it might get confused. And when it gets bigger, you can encounter lots of problems. So now let's go to the DNS, turn it on. So it's very simple. Here we put the name of the website. Let's say we put the domain www.google.com, and here is the IP address 192.168.1.1. This was the IP address for the Google. And let's click on add. Now we have the Google and the IP address for the record 0. Okay, and let's add the Yahoo as well. Alright, the IP address was 192.168.1.2, and let's add it. Okay. Now the thing that we need to do is to go here in the Google server. We need to set up the HTTP service for our servers. Just like everything else, we need to turn off everything for it. But it's not necessary right now because it's a very small simulation. If you have a bigger problem, if you have a bigger projects, you should turn them off manually. But in this case, I don't think we encounter any kind of problems. So turn on the HTTPs, and in the files that we have here is the files that we're gonna show to the user when they enter our URL, enter our domain. So in web development, if you have any knowledge, you know that the first file, the default file that it's gonna open in the browser when we request anything. So let's say we request google.com. The default file that it's gonna open is index.html. So this is the file that I'm gonna open after we enter our URL. So let's click on edit. Here is a basic HTML code. So I'll delete everything here, and here I'm gonna write welcome to Google. Okay, save it and overwrite it. Let's copy this and go to the Yahoo. There isn't any other configuration that you need to do for the HTTP service. Go to the index.html, and here I'm gonna say welcome to. Okay, it's not writing. Yahoo. Okay, save it and overwrite it. Now let's test the simulation that we have created. Let's delete this text as well, and go to the computer. We have a web browser here. Let's open it up and type google.com. Say go. Okay, I think we need to set the www as well. Go. Okay, you can see here it says welcome to Google. So the address that we entered, it connected automatically from the DNS to the server that we put it, and now it is connected to the server. So let's test Yahoo as well. The www.yahoo.com. You can see it now connected to the Yahoo. If we put the IP address directly, let's say for example 192.168.1.1, it should connect to the Google, as you can see. Let's create some IoT simulations. So In order to create an IoT simulation, let's first add our server, because we need a server to communicate between the IoT devices and our other devices, like if we want to control the IoT devices with a smartphone, a home computer, or a laptop. So first we need a server, then let's add a home computer for controlling the devices. And since we are in the end devices, let's add our IoT devices as well. I want to add a coffee machine, ceiling fan, let's add a door, or no, I don't like a door. Let's add a garage door. Okay. And let's, okay, I want a light. All right, now I need a switch to connect everything together. Let's add a switch. And so in the previous versions of Cisco Packet Tracer, you could have connect your IoT devices directly with wire to the switch. So but in the newer version of Cisco Packet Tracer, like my version that I'm using, you cannot connect your IoT devices with wire, so they are all wireless. I need an access point to connect my IoT devices to the switch. So, I'm sorry, connect my IoT devices to this server. So if you are using a previous version of Cisco Packet Tracer, you might be able to connect them with wire directly to the switch. You don't need an access point. But if you want to have an access point, you are free to do anything you want. Okay, so let's first connect the access point, switch, and server and my PC all together. And then let's go to the access point, go to config, and let's have an SSID for our access point. I will add dgdev, and let's copy it here in the config, in the wireless, set the SSID. I didn't set any authentication, so it will connect without needing be entering any password. Alright, now our devices are all connected. So before we go to controlling the devices and any IoT section, let's go and create a DHCP service in our server, because I don't want to give all of the objects IP by hand. So let's go to DHCP, turn the DHCP on. Oh, before we need to set an IP for our server. So let's set an IP of 192.168.1.1 for our server. I will copy the IP. Let's go to services. Now let's have a start IP address. It's going to be 192.168.1. I want to start from 10. Okay, this is going to be 255, 255, 255. And let's say we have 100 devices. All right. Let's save it, and let's go set our devices to DHCP. All right. DHCP request successful. And I believe the IoT devices, if I remember correctly, yeah, they are by default on DHCP, but they are getting an IP out of range that we set to. So we need to put them on static and put them on DHCP again. So you can see the IP has changed and it is on a correct path. Okay, let's test it again. Okay, now all of our devices have an IP address that we can communicate with all of the devices directly. Okay, now let's go to our server. Before we go in IoT part, we need an username. So we have an application here on our server, installed in our server, called IoT Monitor. Let's go to IoT Monitor. Here you can see we need to log in, but we don't have an account to log in right now. So there isn't any sign up either. Let's log in with the false information. If I click on login, it should give me an error. Okay, let's put the IP address of our server first. Login, file not found. Maybe the services should be on, huh? Okay, let's try again. The IP address of our server. Okay, now you can see it says the login wasn't successful, and now we have a sign up now. So one mistake I had, we need to turn on the IoT first. So, all right, and let's sign up now and set a username and password like admin and create. Okay, now we have an IoT service logged in our server, and in our services, I don't have any IoT device connected right now. Let's go to the desktop. Here is the visual part that we can communicate with our devices. For example, turn the coffee machine on or off. We can do it from the server as well, from here. So now let's connect our IoT devices to the server. In order to do that, let's go to the IoT device. We go to setting, and at the bottom here we have an IoT server. So the IoT server, put it on remote server. Here we need the server address, so it was 192.168.1.1. The username and password was admin. I click on connect. Connecting. If the connection was successful, here the button will be refresh. So let me show you with another device what will happen if we set a wrong username and password. So let's say we say admin 123 connect. Okay, you can see it remain connect. So the username and password wasn't correct. If the username and password be correct, it would be refresh. Okay, you can see it connected successfully. And for the other devices, we need to do it as well. Okay, the last device. All right. Okay, connect. You can see now all of our devices are connected to the server. Let's go to the server. Let's go to IoT monitor, and you can see all of our devices: the ceiling fan, the garage door light, and the coffee machine. And now how we can communicate. Let's just in order to communicate, let's just click on it. Here we have a button called on off. You can see when I clicking on it, the device here, the light here is turning on and off. So right now it's off, right now it's on, and again off, on. Okay, so we can have a communication with our devices through this application. And if you want to turn them off and on by hand, so you don't want to have anything like from server or from a computer, you just hold Alt on your keyboard and click on the objects. So if I hold Alt and click, you can see I can turn them off and on. And it's for ceiling fan as well. So ceiling fan, if I click again on it, you can see it has a light mode and a turbo mode, I think, and it will then turn off. So it is off, light mode, turbo mode, and off again. Okay, so how we can control them from our home PC now? It's as easy as drinking water, and let's just click on the computer in the desktop tab. We have an IoT monitor as well. Let's click on it here. We set the server IP address, username and password, and log in. Now we have access to all of the devices from the server, and we are controlling them through our home PC. And let's go, for example, for the ceiling fan. You can have off, low, high. Okay, and for the garage door as well, and all of other devices. Okay, guys, that's it. I believe this is the last video for our beginners tutorial course. So if you want any other tutorial in this, because we just scratched the surface of Cisco Packet Tracer, you have so many things to do in Cisco Packet Tracer. There are so much you can simulate. In IoT, for example, here we have a car. You can have sensors inside the car, so they will check if the gas inside the garage door is in a level that you set. You can open up the garage door. So you can have so many conditions. Based on the conditions, something happens. They could have all of those in Cisco Packet Tracer. There are so much things you can do with Cisco Packet Tracer, and we just scratched the surface. This was just the beginner course. And if you have anything special in mind you want me to create a tutorial for in Cisco Packet Tracer, just let me know.